Section 7-2, division properties of exponents. First property is the quotient of powers. To divide two powers with the same base, subtract the exponents. So a raised to the power of m divided by a raised to the power of n is a to the m minus n power. When you're dividing, subtract the exponents. So x to the fifth divided by x to the third is x to the 5 minus 3, or x squared. Here are some examples. Simplify each expression. A to the fifth times b to the fourth divided by a times b squared. You want to look at the a's, so that's going to be a to the 5 minus 1, because the exponent right here is 1. So that's going to give me a to the fourth divided by, and then times b to the fourth divided by b squared. That's b to the 4 minus 2, or b squared. The other way to think of this, remember, let me just take a part of this here and show you what's going on here. So a to the fifth divided by a. Remember, a to the fifth is actually 5 a's being multiplied times each other. And then you have 1a on the bottom. So what happens? This 1a on the bottom cancels with 1 on the top. What you've basically done is taken the 5 a's on the top and then kind of canceled it out with 1a on the bottom, so it's like doing 5 minus 1 to give you 4. Here's another example. 6x squared times y cubed divided by 2xy. Don't subtract your coefficients. This is just the same as 6 divided by 2, which gives me a 3. X squared divided by x. You can think of this as x times x on top, 1x on the bottom. So I'm left with 1x. X to the third divided by y gives me y squared. Here's another property. Power of a quotient. To find the power of a quotient, and remember, a quotient is what you get when you're dividing, so that involves division. To find the power of a quotient, find the power of the numerator and the power of the denominator. So a divided by b, all raised to the power of m, is the same as a to the m divided by b to the m. Here's an example. X divided by y, x over y to the third power, is x to the third divided by y to the third. Here's a couple examples. So the fraction 2x squared y divided by 3, all raised to the third power, is the same thing as 2x squared y to the third power divided by 3 to the third power. That exponent applies to both the numerator and the denominator. And remember, we did this in the last section. 2x squared y, whole thing cubed. This 3 is not multiplied by the coefficient 2, but it's actually 2 to the third power times x squared to the third power times y to the third power, all over 3 to the third power, or 2 to the third power is 8, x squared cubed is x to the 6th, y cubed over 3 cubed is 27. Here's another example. 6a squared b cubed divided by 7x, the whole thing squared, is going to be, this squared applies to the 6, so 6 squared is 36. A squared squared is a to the fourth. B cubed squared, multiply those, is b to the sixth. And then on the bottom, 7 squared, it's not 7 times 2, it's 7 squared is 49, and then x squared is x squared. Next property is really easy. The zero exponent property. Any non-zero base raised to the 0 power equals 1. In other words, anything raised to the 0 equals 1. A to the 0 is 1. 7 to the 0 is 1, x to the 0 is 1, even some complicated expression raised to the 0 is 1. I don't know why I wrote y in there. I'll explain that when I get back. Let's do a couple examples here. Negative 243, x to the 5th, y cubed, the whole thing to the 0 power, 1. Whatever's in the parentheses, it doesn't matter how ugly or how nasty it is, if the whole thing in the parentheses is raised to the 0 power, it equals 1. Sometimes just one part of the problem will have a base raised to the 0 power. So notice here we have a z to the 0 power. That's just a 1. And remember, when you multiply anything by 1, it doesn't change anything. So I'm just pretty much going to ignore that. X to the 5th divided by x squared, x cubed. Y to the 3rd divided by y squared is going to give me y to the 1, or 1. And y to the 1, and z to the 0 is just 1. So I leave it like that. Now here's the difficult part of the lesson, dealing with negative exponents. So a base raised to a negative exponent, a to the negative n, is the same thing as 1 over a to the positive n. And a over a to the 1 over a to the negative n power is the same as a to the n. Here's some examples with numbers. X to the negative 1/3, x to the negative 3 is the same as 1 over x cubed. And 1 over x to the negative 3 is x cubed. So expression is not simplified if it has a negative exponent. Here's my rule. Here's the way I understand dealing with this. You can't have a negative exponent, but in order to make a negative exponent positive, you need to take the whole power and move it over the fraction bar. Here's the idea. A to the negative n is the same thing as though you were putting it over 1. In order to make this exponent positive, I have to take this whole expression and move it down below, like I did over here. Notice there's nothing left on top, but I got to put a 1 there, and my exponent can become positive. Same thing here. Here's my power that has a negative exponent. If I move it up above, it can become a positive exponent. To make an exponent positive, move the whole power over the fraction bar. Let's do a couple examples with this. X to the 8th divided by x to the 12th. Using our property that says we subtract, that would be x to the 8 minus 12. I'll go ahead and write that out. Or x to the negative 4th. I can't leave a negative exponent in the problem, so that's going to be the same. It's as though this were over 1. I can take this whole expression. If I move it below the fraction bar, I can actually make it positive. So that's going to be the same as 1 over x to the positive 4. Let's take a look at this problem here. Here's how I like to do this. There's only one a in the problem. I'm going to take this one and move it down here. That's going to give me a positive, an a to the positive 3 on the bottom. I have a negative exponent here with d to the negative 6th. I'm going to move it up there, and I can have a d to the positive 6 on the top. Look what's happening with my b's. They will cancel each other out. So what am I left with? On top, I have a c squared. That guy stayed put. He didn't move. This d to the negative 6th, if I move him up on top, I can make it a d to the positive 6. And the a to the negative 3, if I move him to the bottom, I can make him an a to the positive 3. Let's take a look at this. Here's how I like to do this one. This one's a little more complicated. I'm going to go back to pink here. I have a negative exponent here. I'm going to move that down below. I have a negative exponent here. I'm going to move that down below. And I have a negative exponent down here on the bottom. I'm going to move him up. So I'm not going to do any simplifying yet. So I have my 32 stays on top. I had a b cubed that stays on top. And from the bottom, the c squared moved up. On the bottom, I had a 4, an a cubed, and what happened? This a to the negative 8 came down and becomes an a to the positive 8. Let's see, I had a b to the 5th down there, and then I had a c to the negative 4th come down below, so I have a c to the 4th on the bottom. Okay, let's make some sense of that. Look at the coefficients. 32 divided by 4 is 8. and that's going to be an 8 on the top because I might have stuff on the bottom. My a's, I don't have any a's on top, but I have an a to the 3rd and an a to the 8th. That's going to give me an a to the 11th. B's, I have 3 b's on top, 5 b's on the bottom. It's as though you can think of it like this: b times b times b on the top, 5 b's on the bottom. What's going to happen? I'm left with 2 on the bottom. And then the same thing with the C's. 2 C's on top, 4 C's on the bottom. Leaves me with 2 on the bottom. That's a little messy. Let's write it more neatly. And that's my final answer. Notice each base appears only once. There's only one A, only one B, and only one C in the problem. And I have no negative exponents, and my fraction, 32/4, has been simplified. Okay, here's a little bit of a complicated one. I think what I would like to do with this is, I'm going to get rid of the denominator first. The 3xy to the negative 2. And let's apply this exponent here to everything in there. So that's going to give me an x to the negative 1 times 3, a negative 3, and then a y to the 3rd. So I've gotten rid of my parentheses. Now I'm going to move things around to get rid of my negative exponents. This I'm going to move down below. This I'm going to move up above. And that gives me a 3x, but we're already on top. And what else came up? An x cubed. On the bottom, I had a 3y, or I'm sorry, a y to the 3rd. And then what came down was a y squared. So let's just pull those things together. That's going to give me a 3. X to the 1 times x to the 3rd is x to the 4th. And then on the bottom, y to the 3rd times y squared, y to the 5th. This is the last one. Okay, one last problem. This one's a little complicated because not only do I have an exponent outside the parentheses, it's negative. And here's the weird thing that does. That negative and the exponent outside the parentheses, it flips the whole fraction inside. So inside the parentheses, I don't change any of my exponents. I'm not dealing with the negatives yet. I'm just going to flip the whole fraction. So let me get that right. And that's raised to the 3rd power. So in other words, I can make this negative 3 a positive 3 if I flip the whole fraction inside. Now I think I'm going to get rid of the parentheses and apply that 3. So 2 cubed is 8. A to the negative 4th to the 3rd is a to the negative 12th. We'll deal with that in a minute. B to the negative 5th to the 3rd is b to the negative 15. 4 to the 0 is 1, so I'm going to ignore that. A squared to the 3rd is a to the 6th. B cubed to the 3rd is b to the 9th. And C is just cubed. Okay, now let's deal with those negative exponents. This one's negative, goes down below. This one's negative, goes down below. I don't have any negative exponents on the bottom, so those guys all stay put. So I'm going to have 8. Actually, all I have left on top is an 8. 8. And then on the bottom, I'll have a to the 12th that came down, a to the 6th, b to the 15th that came down, and b to the 9th was already there, and c to the 3rd was already there. That leaves me with 8 over a to the 18th, b to the 24th, and c cubed. It's funny looking, but it's right.